Hello, students. This is Ishan Akbar. In this lecture, I would teach you that how to calculate the elastic settlement under newly constructed foundations or newly constructed structures. So, before starting with the example and background, I would like to introduce that what is the elastic settlement. So, basically, elastic settlement occurs beneath the shallow or deep foundations, and this settlement is just after the construction. So basically we calculate the elastic settlement within all types of soils. The base soil or the site soil may be clay, may be silt, sand, or gravel. Any type of soil may undergo elastic settlement just after the construction of the structure, or even it can happen during the construction phase. Mean whenever you are going to construct or you are constructing any structure, your structure may go under elastic settlement. So basically, there is a clear difference between elastic and consolidation settlement. That consolidation is due to removal of water and it does not start at the initial stage. It takes time to start for the consolidation settlement, but elastic settlement starts just after the construction of first phase. Mean whenever you are laying down your foundation, it will start, and it may takes 1 day, 3 days, 7 days, or ultimately it may take 1 year to complete. But this settlement remains at the site for shorter duration as compared to consolidation settlement. So, in this lecture, we will discuss the uh, elastic settlement on of the shallow foundations on saturated clays. Here we will take the example of those clays which are saturated having a Poisson's ratio of 0.5. To find the elastic settlement, I will take this example that let us say there is a foundation on the soil. This is a compressible material. Mean this soil may be sand, may be clay. In our case, this will be saturated clay, but this may be sand, this may be clay, this may be silt, and this may be gravel. On this site, if a foundation is applying a pressure of Q naught, mean a bearing pressure, that it may be load per unit area. That is the pressure being caused on the soil because of foundation. And this foundation is laid at the depth of DF, and we have an impermeable strata at the downside of the soil. The depth of an impermeable strata from the base of foundation to this impermeable rock or any strata is h. Mean distance from base of foundation to the impermeable strata is known as h. This is height of the soil from base to impermeable rock. And we will automatically determine different things. This foundation will have a width of b, will have a length l, and other parameters like over consolidation ratio, that is OCR, undrained shear strength, that is CU, and other characteristics of the soil will be given. So this formula is used basically for the calculation of elastic settlement of shallow foundations on saturated clays. This factor A1 is determined from graphs. A2 is also determined from graph by various factors. I will let you know. Q naught is the applied stress at the foundation level, B is the breadth of the foundation, and ES is the modulus of elasticity of the soil. So A1 basically depends upon H by B and L by B. Mean you will have B and L for the foundation. You have to find L by B and H by B from the given data. This H will be given, this B and L will be given. So you will find out A1 from the graph. Means A1 is the function of H by B and L by B. And on the same in the same way, A2 is the function of df by b. We are given with the df BF is also, B is given, so we will find this value of A2 using DF by B from graph. L is the length, B is the breadth, DF is the depth of foundation below the soil surface, H is the depth of the bottom of foundation to a rigid layer. This layer means this layer is incompressible. No, we are not concerned that how much load is applied. There will be no compression in this layer. So basically, the background is that if we have a incompressible layer below our saturated clays, then we can use this formula. Otherwise, we will be unable to use this formula for calculation of elastic settlement. And Q naught is the net load applied per unit area of the foundation. I already told that this Q naught is equal to P by A, force per unit area. So for this, we are going to take an example. Refer to figure. Let us say this is the figure uh, where a 2 meter by 3 meter flexible foundation is placed in a saturated clay at 1.5 meter depth. Mean value of B is 2 meter. Value of L is 3 meter. B is equal to 2 meter, and at a 1.5 meter mean depth of foundation is 1.5 meter. So we will write df equal to 1.5 meter. Bedrock lies at 4 meter below the foundation, mean this is foundation level, and below the foundation the level of bedrock is 4 meter. So we can say that h is equal to 4 meter. So then the clay is over consolidated with OCR. This is the clay layer, and OCR of the clay layer is equal to 2 with an undrained shear strength of means Cu is equal to 60, and plasticity index Pi, plasticity index of the soil is 45. So this is the soil data. If the pressure applied by the foundation to the underlying soil is 80 kilopascals, mean we are given with the Q naught. This Q naught is equal to 80 kPa, kilopascals. Then determine the average elastic settlement, that how much elastic settlement will occur due to construction of this foundation, type of flexible foundation on the clay. We will need to determine ES, then we'll find SE, elastic settlement. To calculate the elastic settlement, we know the formula, that is A1, A2, Q naught, B over ES. We are given with Q naught, that is 80. We are given with B, that is 2 meter, but we need to determine A1, A2, and ES. So first of all, we will determine A1. For A1, we saw that this is the function of L by B and H by B. On the last page, we saw that A1 is the function of H by B and L by B. So one by one, we will calculate this L by B. Let us see what is L by B here. Length of the foundation is 3 meter and width of foundation is 2 meter. So it will be equal to 1.5 meter will be cancelled. And H by B, H is equal to 4 meter and B is equal to 2 meters. So it will be equal to 2. When we have found these two parameters, we can directly go to the graph for A1. This is the graph for A1, mean vertical scale shows the values of A1. We will see that what type of foundation. If we have circular foundation, we will follow this line. If we have square foundation, we will follow this line, mean L by B is equal to 1 in this case. And if for square case, if we have ratio of L by B equal to 2, we will follow this line. L by B equal to 5, we will follow this one. Let us say we have a ratio of L by B equal to 4, then we will divide this in three parts, and we will follow the same trend like this one. And then for L by B equal to 4, we will follow straight line like this line. So in our case, L by B is equal to 1.5. So basically, we will draw a point between 1 and 2, and we will move in this direction like this curve. Say this is the curve in red for one point L by B equal to 1.5. If I will raise other values, so our value for L by B is equal to 1.5. And what is value of H by B in our case? That was equal to 2. So this is 2. We will draw a vertical line for H by B is equal to 2. Where this line meets this curve of L by B, we will draw a horizontal line and we'll see that what is the intersection point of this horizontal line. This is intersecting at zero point 0.6. So we can say that value of A1 is zero point 0.6 simply. So we have found the value of A1 as zero point 0.6. In next phase, we have to determine the value of A2. As we saw that A2 depends upon the value of df by b. So what is df here? That is 1.5, and what is b? That is 2 meters. So we'll get an answer of 0.5, 0.75. For this 0.75 value, we'll go to the graph of curve of A2 and we will draw a vertical line corresponding to 0.75 of the df by b, and then we will draw a horizontal line where this line will meet this point. Say this is 0.94, and this is the value of A2. Now we have only single thing remaining, that is ES. To calculate ES, we are given with the values of CU and OCR and PI. In our question, OCR is equal to 2, PI is equal to 45. Using these two values, we will determine the value of beta, and this beta will be multiplied with the CU to get the value of ES. We have CU with us 80, but we don't have beta. To calculate beta, we can use this table. So basically, we will see our OCR value, where the OCR value of 2 exists. This is the OCR 2. It means that we have to follow this column with a value of OCR equal to 2. Now, we will find the plasticity index of 45. Plasticity index of 45 exists within this limit, 30 to 40, mean we have to move in this direction. So our value of beta will be from 270 to 550, maybe any value. So the best method is to interpolate. We all know that how to interpolate different values. So what is difference of these values? This is 50 minus 30. That is equal to 20. And what is difference of 550 minus 270? Say 550 minus 270, this will be 280. Means for 20 intervals, we have an increment of 280 values. Mean a value of beta increases or varies 280 times for 20 times value of pi. It means for what will be value of beta for one value of plasticity index? Simply 280 divided by 20 means value of beta per pi. That will be equal to 14. 0 cancels with 0, and this is 14. So for each single number of pi, we will have an increment or decline of 14 in the value of beta. So say the value of beta at 50, because 45 is near to 50, so we will take it as reference. If there is any value which is near to 30, we can take the reference of 30. The value of, if the value of pi is 50, then value of beta is equal to 270. Higher value 50 indicates the lower value of beta 270. If pi is equal to 45, then what will be the value of beta? Simply, we will use algebraic formulae 270, because if the value of beta pi decreases, the value of beta increases. Means if we are at 30, the value of beta will be 550, and if pi is 50, then value of beta will be 270. Mean they are inverse. Mean if we want to go from 50 to lower value, then we have to add something, because it's increasing from 270 to 550. There is an increasing trend. In all cases, we will follow same thing. If we are moving from 250 in higher value to lower value, then we will put positive sign. If we are moving from lower to higher value, then we will put negative sign with 550. Plus, what is difference between 50 and 5? Simply 50 and 45. 50 minus 45. And what is change per unit pi? That is 14. Just write this one. So beta will be equal to 340. So the value of beta is 340 in this case. When we have determined the value of beta, now it is very simple to calculate the value of ES. Beta is 340 times 80. If we multiply this beta of 340 with 80, then we will find the value of ES as 27200 kilopascals, because the unit of Cu is kilopascals. Beta is unitless quantity. So all the unknowns are here. Now we can use the formula of elastic settlement: Se A1 A2 Q naught B divided by Es. So simply put the value zero point 0.6 of A1, 0.94 of A2, Q naught is given to be 80. I will check. Sorry, Cu is 60 here. Cu is 60 and Q naught is 80. So sorry, we will revise the value of ES. Here we will use 60. So it will not be 27200. We will have a different value, 20400. 20400 kPa. Sorry for this. And Q naught is 80 times 20400 divided by, sorry, B. B is 2 meter and this is 20400. ES is in the denominator. So we'll just multiply and divide relevant values and we'll see the answer. This is zero point 0.6 times 0.94 times 80 times 2, and divide this by 20400, will get as 0.442, sorry, 0.00442 meters. The answer will be in meters because the unit of B is meter. This is in kilopascals and this is in kilopascals. So kilopascal will be cancelled with kilopascal and we'll have net unit of SC equal to meters. So if we want to convert this in millimeters, so SE will be equal to 0.00442 meter, multiply with 1000 and divide with 1000. This 1000 will be converted to milli and this 1000 will be multiplied with this value. So SE is equal to 4.42 millimeters. So basically this is the elastic settlement that can happen on site due to construction of uh, our described foundation on saturated clay with specific properties. So in this question, the elastic settlement of this soil will undergo an elastic settlement. SE of 4.42 millimeters. So this is the elastic settlement procedure on saturated clays. For any other type of soil, we use the Schmertman methods. In next video, I will discuss this method to determine the elastic settlement under the foundation. This method is also known as the strain influence zone method. Strain influence zone method. See you in the next video. Take care. Thank you for watching. Kindly subscribe my channel. Till next video, take care of yourself. Allah Hafiz.